All right, so let's talk about this bottom question. It's asking if this graph represents the height of a ball in the air, where x is the time in seconds and f of x is the height in feet, what information can you draw from this graph? So what can we say about the ball according to this picture, according to this graph of this quadratic? All right, so I'm just going to put it, time is our x. So my x-axis is going to represent time. So this would be 1 second, 2 second, 3 second, 4 seconds, etc. My y-axis is going to represent height, right? Because there's our independent variable is in the function and our dependent variable is what comes out. So this would be 1 foot, 2 foot, 3 foot, 4 foot, right? And as soon as I label that, it doesn't really make sense for me to even pay attention to negative x values or negative y values. So I'm going to go ahead and focus all of my attention on the first quadrant, right, where we have both positive height and positive time. Okay, so take a second, pause the video, and think about it. What does this picture, what does that picture tell us about the ball? All right, I can pick up on three and a half things. I count them as 3 things, but there's really 2 pieces of information in one of them. All right, the first thing that I notice is that if this was a ball, it starts here, which is interesting. It's not starting on the ground. All right, the ball starts at 5 feet high. Okay, maybe someone's holding it, that's 5 feet high. Maybe it's being launched out of one of those t-shirt cannons, and its starting height is 5 feet above the ground. It's pretty cool. So then as the ball starts to travel up, it hits the vertex. And the vertex is the one that tells us 2 different things. First of all, I notice that it goes up to this point and then the ball starts to come back down. So the ball itself reaches a maximum height up here at what would be 9 feet. So the ball reaches a max height at 9 feet above the ground. So it's thrown up into the air. The highest it gets is 9 feet up into the air, and then it starts to come back down. Okay, well, another piece of information that we can pull from that vertex is the time it takes to get to that height. We started at 5 feet. And then they start the stopwatch and it starts to rise up and it counts 1 second, it's at this point, at this height, and then after 2 seconds, it's at its maximum height. So the ball reaches its maximum height at 2 seconds. So it takes 2 seconds for the ball to get to its maximum height. And then the last thing that I notice is the ball comes up to this maximum height, it hits this height on the way back down, it keeps falling, keeps falling, keeps falling, and this x-axis here, where the height is equal to 0, would probably most likely represent my ground, right? If you're no height above the ground, you're at 0 height. You're on the ground. All right, so the ball does come back down all the way to the ground, and it takes 1, 2, 3, 4, 5 seconds to get there. So the ball takes 5 seconds to reach the ground. Okay. Some of the other things that students have told me in the past is that, the ball's in the air between 0 and 5 seconds, or the ball reaches any height between 0 feet and 9 feet, talking about the domain and range. You can say that it goes up, reaches a maximum, and comes back down, which is awesome. But if you have any other suggestions, let me know, and we'll see if your thoughts line up. All right, but these 3 features, where an object starts, which would represent my y-intercept, okay, what its maximum height or minimum height and how long it takes to get there, this would be the vertex. And how long it takes to reach the ground, that would be our roots. Get it? Roots on the ground. Those are our key features of a parabola, and they're also the most common questions that word problems are going to ask us. So we're going to use your skills that you already have of finding these 3 features in order to apply them to real-world applications. All right, so let's jump into the note sheet. Okay, I'm going to start with this first question in the top left-hand corner. Now for the first 3 on the left-hand side, which are the 3 that I'm going to go through together with you, because I would normally be doing this in class and we would be talking about it together, I left off the fact that the input, the independent variable in each case, represents time in seconds, and then the output or the dependent variable represents height in feet. All right, so let's just overall cover that. For example, in this one, t is going to be time in seconds, and h of t is going to be the height in feet at a certain time. Okay, so let's read this question. We're talking about the height of a basketball shot into a hoop represented by the function h of t. The question it's asking is how long until the ball reaches its maximum height. And I actually brought out some markers here so that we don't have to, you don't have to squint. All right, but how long until it reaches the maximum height? All right, so if you're picturing a parabola in your head on a graph, this would make, and this is a very rough sketch, this would make some sort of frowning upside down U shape because we have that negative 16 as our A value. So my maximum height would happen at the vertex, right? The height that it reaches before it starts coming back down. But the time, or how long it takes to get there, since time is our independent variable on our x-axis, that would actually be the axis of symmetry, or the x value of the vertex, whichever way you want to think of it. So in order to answer this question, you're going to find the axis of symmetry of the quadratic equation up here. Okay, so hopefully you remember the formula for axis of symmetry. It's one that we have to have memorized. It won't be given to us. X equals negative b divided by 2a. Now, in this case, we're not using x's, we're using t's. So if you remember to make that switch, I'm going to start my work over here. T is going to be equal to negative b, which is 30. Put the negative on the inside. I want the negative on the outside. Divided by 2 times a. Okay, now be careful if you're going to go into your calculator and plug this in. You want to make sure that you plug it in correctly in the fractional format. All right, because you'll notice that this simplifies to negative 30 over negative 32, which unfortunately doesn't divide out very pretty. All right, but you should get t equals 0.9375. And it's a short enough decimal to write, so I'm going to write the whole decimal because they didn't give me the option to round. So in this case, to answer the actual question, since time t represents time in seconds, then I'm going to answer it with 0.9375 seconds. They're very specific in timing this basketball. And that's it. Okay, let's move on to the next one. Go ahead and read it to yourself. Pause the video if you have to. All right, we are focusing on the function f of t. Again, where t is going to represent time in seconds, and f of t is going to represent height in feet. Oh, no, you know what? Meters for this one. I just read the question again, and it says round to the nearest meter. So we do get to round for this question, which is a bit of a heads up. We're probably going to have a messy decimal to work with. That's okay. We're capable of doing it. But they're asking us, what is the maximum height? So again, if you picture this on a graph, I've got my negative a value. It's going to make some sort of frowning parabola shape. The maximum height is corresponding to the vertex, that turning point at the top of my parabola. But now in this case, they're not asking us how long it takes to get there, so we're not concerned with time. We're concerned with what is the maximum height, or what is the y value of the vertex. So where does it reach up on the graph? So in this case, we're going to be finding the vertex, and more specifically, the y value. Okay, so algebraically, if you remember, when a quadratic is in standard form, in order to find the vertex, we actually have to go through the axis of symmetry. So I'm going to use the same formula, negative b divided by 2 times a. So in this case, t is equal to, I'll give you a second to plug it in. And you do get a messy decimal here. Remember, even though it tells you that you can round to the nearest meter at the end, when we're in our work and we're still planning to use things, we're not at the final answer, we want to go a little further than we have to. So I rounded mine to 4.082 just to be safe, giving myself a few extra digits. All right, but that's the x value of the vertex. That's the independent variable, or the time it takes to get there. How do I find the height that goes with it? Okay. All I have to do is take this number, 4.082, and plug it in to my function. Okay, so I'm going to replace all of my t values, 4.082 squared plus 40 times 4.082 plus 1. And I'm definitely going to reach for my calculator, plug that in as one statement, hit enter, because that is a messy decimal to try to square. And if you do that, f of 4.082 is equal to 184.2818. All right, so the height would be somewhere around 184 feet. They did say to round to the nearest meter. So I keep saying feet. My height would be 184 meters in the air. That would be the maximum height that the arrow is going to reach as he shoots them straight up into the air. All right, third one here is about a Fortnite battle. I hope this is still relevant, and people are probably playing more Fortnite than ever as we're quarantined at home. But we have grenades being thrown at an enemy target, so they're going to take that same sort of parabolic shape. You're going to throw it up into the air, and what goes up must come down. So we have this function h of x to work with that represents the path of our grenade. In this question, they're asking, what is the height that the fort is, that the grenade is thrown from? So how tall is the fort that someone's standing on to throw the grenade, or that it's being launched from? I don't know how Fortnite works. And I gave you a hint here, the initial height of the grenade. Okay, so again, boom, boom, I'm picturing this kind of little frowny thing. If I'm looking for the starting height or the initial height, or where it is before it gets thrown, I'm looking for where it is when time is 0. So it's kind of hard when you have the 4 quadrants to deal with to kind of picture it. But remember, if your independent variable, of course, in this case is x, represents time, an x value being equal to 0 would put you right here on the y-axis. So they're asking you to find the y-intercept. All right, that's going to be a giveaway for you guys, and I hope you guys remember that. If they ask for initial height, starting point, look for the y-intercept, because you're starting at a time of 0. Okay, now, how do we find the y-intercept? That's where x value is 0. Right, when our time is equal to 0 in this case. And you might jump right away to replacing all of your x values with 0 and plugging it into your calculator. But that's actually a waste of time and a waste of your energy. Remember, if a quadratic is in standard form, your y-intercept is given to you, because plugging in 0 is going to take out these two terms and move them to 0. So my height at time 0 is going to be equal to 10. All right, so we'll say that this one is in feet, like we're living in the real Fortnite battle. So we'll say that the height of the fort is 10 feet. Okay. Now, I would like you guys to trying to get out of the shadows here. I would like you guys to try the 3 on the right-hand side. Okay, what I'm going to do for you is I'm going to give you a nudge in the right direction, and I'm going to go through the toughest part of these problems, which is usually just to figure out what are you supposed to be looking for. All right, so let's read through these 3 really quick. I'll give you the hint as to how to get started, and then you guys will be in charge of figuring it out on your own, and you can do that. All right, so the first one up here, the profits of Mr. Grable's T-shirt company is given by this equation. Boom, that's our mathematical focus. Y is the profit, and X is the number of years in business. So how many years will it take until Mr. Grable shows a maximum profit? What I want you to focus on is how many years. You have to answer that question. So your answer is going to be something along the lines of X equals, because X is the number of years. But they want to know specifically how many years will it take for Mr. Grable's company to reach a maximum profit. Okay, maximum profit, maximum height, maximum value, they all help us think about the vertex. So this is asking you to find the vertex. Because you want to know how many years, you're looking for the X value of the vertex, aka the axis of symmetry. So question number 1 up here, very similar to question number 1 over there. I almost did that on purpose, but it works out much nicer. So, okay. The second one, and again, that's up to you. I'm going to leave you to do that. You can do that. The second one is going to be about a football kicked for a field goal, right? Kicked up. What goes up must come down. And we're looking at this quadratic to focus on. T is the number of seconds, and h of t is the height. Okay, now this one couldn't be more obvious as to what we're finding. They literally ask you, what is the vertex? So very similar to this question on the left-hand side, you're going to find the vertex. Remember, the vertex is x comma y, so something comma something, fill in both blanks. And then it asks you to figure out what does it mean in the context of this problem. And anytime they ask you that, they want you to describe what your numbers mean according to the height of the football kicked for the field goal. So use words like seconds, feet, football, bring it all together with a nice statement that you can summarize your findings. Okay? And then the last one is the reason that I'm going through and giving you guys a helpful hint is because we didn't really do an example like the last one yet. I have full faith that you can figure it out, right? But it's about the graduates at the graduation ceremony, which fingers crossed will still happen for them this year. They throw their hats up into the air and they make a parabolic shape because what goes up must come down. And then someone figured out that the function y equals negative 16x squared plus 32x plus 5 represents the height of the hat. Okay. In this case, again, I don't think I actually specified it, but x is going to represent time in seconds, round to the nearest second, and y is going to represent height in the air. Okay. So the question is, how long until her hat reaches the ground again? So she's going to throw it up in the air, it's going to come back down, it's going to hit the ground after a certain amount of time, and that's what we need to figure out. Okay, so for this one, I just want to draw that picture. Again, we have a negative a value, so I'm picturing one of these frowning parabolas. Okay, if it starts at this height, she throws it up into the air, it starts to come back down, hitting the ground in this case is going to represent the root of our quadratic. Now, there are 2 roots in this quadratic and in most quadratics that we're going to deal with. You want to focus on the root that is positive. Okay, so how do we find the roots? We set y equal to 0, so you're going to replace the y with the number 0, and you're going to solve for x. And I know that this is probably the most work on this entire worksheet, but again, you guys can do this. All right, I'll give you the helpful hint that you are given the quadratic formula. It's in your notebook. Hopefully you have it. But if not, x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, that's what you're going to use to solve this equation after you replace the y value with a 0. Okay, but that's just one of the methods. You could use other ones. And then round your answer to the nearest second and make sure it makes sense in terms of how long it takes her hat to reach the ground again. Okay, I have full faith in you guys. Try them. There's no one around to tell you that you did it right or wrong. That's my job. So what we're going to do is we're going to meet again for a Zoom meeting on, what's today? Oh, we're gonna meet today, Wednesday, at 2 o'clock. 2 to 3 o'clock will be my office hours. You don't have to come if you think you got the hang of it. Awesome. I'll post the answer key to this at 2 o'clock on my website. So if you want to just check in, check your answers, and you get 100, then you don't have to see my face. But if you look at the answer key and you didn't get the right answers, or you're looking at these questions and you have no clue how to do it, then you should join our Zoom meeting at 2 o'clock, anytime, I should say, between 2 and 3. You don't have to be there at 2 o'clock for the entire time. And that's when I'll be taking questions and I'll be going through problems and I'll be asking you guys what you're confused about and going through extra problems if necessary and explaining what the process is for each one of these. So that's going to be like our virtual extra help. All right. I hope that you guys feel comfortable doing this based on what we've done all year. I hope you guys are staying healthy, you're staying sane, you're getting outside as much as you can in a safe way. I had to sit outside. It's just way too sunny to not. And hopefully I get to see your beautiful faces this afternoon. Have a great day, everyone. I miss you.